Hi everyone, this video is the solution to example 4 on the topic of unit load method. In this case we're going to be doing a two-dimensional frame, so it has a column and a beam, and it has some distances 4 and 6 and also has a UDL on top, and we also know the rigidity EI is constant throughout the frame. In this particular case we're interested in finding the rotation at point C. So we're interested in finding this rotation theta at point C. So again, the first thing we need to set up is the real structure and the virtual structure. So the real and the virtual are going to look exactly the same. The only difference is the real one will have the original loading. So in this case, it's just a UDL of 1, while the virtual will have a moment of 1 because I'm interested in getting the rotation at point C. So we put this moment as well in point C to get the rotation at point C. And this is it. So once we get this, we're going to go straight into the bending moment diagrams. And here for these bending moment diagrams, if they start getting a little bit too complicated, I suggest you watch the videos on the topic of frames to help you with this. But in this case, if you want to do the real one first, it's a good idea to try to get this reaction here on the bottom. So the load of 1 will try to rotate this clockwise. So this reaction is going to be counterclockwise. And the value of this will be 1 times 4. So that's the value here is 1 times 4, and also times 2, that's 8. So this reaction here must be equal to 8. And another thing we can find out is that the shear force, so the horizontal reaction will be 0, which means the shear force in the column will also be 0. So I can find out straight away that the tension is going to be on the left side, and this is going to be constant with a moment of 8. Then this transfers outside, so that's also going to be 8. And then a UDL, so we need a parabolic moment over there. Okay, looking good. So tension on the top, tension on the left. It's looking good. Now if we go into the virtual, we have constant of 1 that then gets transferred as well there. So that moment is going to create a moment of 1 on the beam. And also the reaction here is going to be 1, which means this has to stay constant all the way there. Since again, this shear force is 0, but in this particular case as well, the shear force on the top is also 0. So this stays constant throughout. And this is it. So if we're interested in getting that rotation theta, is nothing more than multiplying these diagrams. So in this case, we're going to do a square times a square for the column. That's divided by EI of the column. Plus a parabola times a square, also divided by the EI of the beam. So again, we go into our table, and our table says that square times square can be found here, so it's nothing more than ACL plus, and now parabola times square is 1 over 3 ACL. So let's write this down. Let's not forget the 1 over EI that I forgot here, so let's put here divided by EI. And now ACL for the first case, let's look at the squares. So it will be 8 times 1, that's the value of A and C, and then the length, we need to go and figure it out, so that's 6 meters. So 8 times 1 times 6 plus, and now 1 over 3, and now ACL will be 1 and 8 again. And now the value of L for the beam will be 4 meters. So it's this dimension there. If you put this in the calculator, we get this is 176 divided by 3 EI. And again, the fact that it's positive means the rotation is the same as I assumed over there, which makes sense with this loading, that point is going to rotate clockwise. So this is it. This is how you calculate a 2D frame using unit load method. So thank you for watching and have a nice day.